Okay, so we have this interesting exponential equation containing the complex value I. So it is 2 raised to power x equals I. So let's dive in. So we have it as 2 raised to power x equals I. We could apply log to the base e to both sides. So we now have it as log to the base e, and then we have 2 raised to power x equals, then we have log to the base e, and then we have our I. And of course, the x can come in this way and be in product with the log 2 base e. So we now have x log 2 base e equals log I to the base e. And of course, we know here we can divide both sides by log 2 to the base e, so that the x will be free. We have log 2 to the base e, and here divide by log 2 to the base e. So this cancels out this. We are left with just x now. So x now is equal to log I to the base e over log 2 to the base e. Then we could still further get a value for log I to the base e. So that's if we don't want to stop here, we could get a value for log I to the base e. How do you get a value for log I? We can have it this way as when you have root minus 1 being equal to I, and then you square both sides. So the 2 here eliminates the root. We now have minus 1 equals I squared. Take note of this. And also when you have e raised to power I pi equals minus 1, take note of this equation also. So we're going to work with this. But remember that minus 1 equals I squared. So we work with this. Working with this, let me write this one out now. We have e raised to power I pi equals minus 1. So writing that one out. E raised to power I pi equals minus 1. Then again, I apply log to the base e to both sides. So log to the base e, then we have e raised to power I pi equals log minus 1 raised to the base e. And of course, we know that the I pi can come in here and stand in product with the log e base e. We now have I pi, then we have log e to the base e equals log, then minus 1. Remember from the equation here, we have minus 1 equals I squared. So I'm replacing this minus 1 with I squared. So I now have I pi log e to the base e equals log I squared to the base e. Then of course, when the number and the base are the same, it means it's 1. So if you simplify this, you get 1. So I now have I pi times 1 equals log I pi to the base e. And of course, I pi times 1 is still I pi equals, the 2 can move over and be in product with the log I to the base e. So that will be 2 log I to the base e. Then dividing through by 2. 2 cancels 2. Then log I to the base e equals, I to the base e is now equal to I pi over 2. So we now have it this way. So we now have a value for log I to the base e, which is what? I pi over 2. So I'll replace log I to the base e with this value. So I now have x equals, instead of writing log I to the base e, I'm writing this value, because log I to the base e equals this I pi over 2 over log 2 to the base e. So this divided by this, if you divide, let's see what you get when you divide. So I have I pi over 2 divided by log 2 to the base e. Of course, this is over 1. Then you now have I pi over 2 times 1 over log 2 to the base e. This times this gives me I pi. 2 times log 2 to the base e gives me 2 log 2 to the base e. So I now have my final answer as, after dividing this by this, I got this. So x will now be equal to I pi over 2 log 2 to the base e. Of course, we know that if the log to the base, if the log is having a base of e, we can write it as ln. So we can see ln2 or ln2. So they are the same. So we can now rewrite this as this 2 log to the base e now becomes 2 ln2. This is the final answer. So that's it. It's very simple.